Good morning, Mr. President, members of the Commission. My name is David Newland, and I'm the Acting Director General of the Directorate of Nuclear Cycle and Facilities Regulation. With me today is Mr. Michael Rinker, Director of the Nuclear Processing Facilities Division. We also have licensing and compliance staff, as well as subject matter experts, with us to help answer any questions that the Commission may have. We are here to present Commission Member Document CMD 14 M59 entitled CNSC Staff Report on the Performance of Uranium and Nuclear Substance Processing Facilities for 2013. I will now pass the presentation to Mr. Rinker. Thank you.
Good afternoon, Mr. President and members of the Commission. My name is Michael Rinker, and I'm the Director of the Nuclear Processing Facilities Division. I will be presenting to you information on the performance of uranium processing facilities and nuclear substance processing facilities. I will also be updating the Commission on matters of regulatory interest, such as an update on the cell room event at the Port Hope Conversion Facility, a status update of the Fukushima Action Plan as it relates to uranium and nuclear processing facilities, the status of the financial guarantee for Best Theratronics, which was recently granted a Class 1B license in June of 2014, and the status of actions that were requested of GE Hitachi Canada by the Commission during the presentation of the 2012 annual report in Toronto in December of last year. The CNSC regulates Canada's uranium and nuclear processing facilities to protect the health, safety, and security of Canadians and the environment. The CNSC achieves this mandate through licensing, reporting, verification, and, when necessary, enforcement. The report provided in CMD 14 M59 and this presentation are organized by industry sector, covering uranium processing facilities and nuclear substance processing facilities. The information presented covers the 2013 calendar year and, where appropriate, compares information amongst facilities and to previous years. Safety performance is continually determined by staff using a risk-informed approach. That is, the compliance program is developed and planned commensurate with the risks associated with the facility, the complexity of the facility, and past performance, and how well the licensee has managed risks. CNSC also verifies compliance through monitoring and desktop reviews of annual and quarterly compliance reports. The compliance program is supplemented with meetings with licensees to ensure clarity of CNSC expectations. Finally, safety performance is also determined through inspection. 23 inspections were conducted by the CNSC at uranium and nuclear substance processing facilities. Some inspections focused on specific safety and control areas, while other inspections cover multiple safety and control areas. Nevertheless, the inspectors strive to ensure that aspects of radiation protection, environmental protection, and conventional health and safety are covered in every inspection. The report format is similar to last year's report. The report focuses on the three safety and control areas of radiation protection, environmental protection, and conventional health and safety, which cover the key performance indicators for the uranium and nuclear processing facilities. The report also includes appendices that provide data to support findings in the report, as well as production data and financial guarantees for each facility. Also highlighted in the report is a discussion of public information programs, ratings for all 14 safety and control areas, a discussion of reportable events, any significant facility modifications, and areas of increased regulatory focus. The report provides the basis for CNSC staff conclusion that the uranium and nuclear processing facility industry has performed safely in 2013, and progress has been made in the engagement of members of the public. An introductory section on dose limits, release limits, and action levels is presented as part of the 2013 report. radiation dose limits, put a limit to dose received to workers and members of the public. Any dose limit exceedance is a violation of the radiation protection regulations. Release limits are used to limit the quantity of nuclear and hazardous substances released into the environment. Exceedance of a release limit is a violation of a license condition, which would result in CNSC enforcement action. In contrast, action levels are a tool used to ensure that licensees are operating their facility in accordance with their approved programs and within the design and operational parameters of safety control systems. Action levels are set at levels much lower than limits to protect health and the environment. As such, exceeding an action level does not indicate a risk to people nor to the environment. Rather, exceeding an action level draws attention to both the CNSC and to the licensee to a potential problem that must be resolved so that release limits and dose limits are not exceeded. I will now present CNSC staff assessment of the performance of uranium processing facilities. Collectively, these facilities refine and convert uranium received from uranium mines and fabricate fuel pellets and fuel bundles for use in nuclear power plants. There are 5 uranium processing facilities in Canada. All are located within the province of Ontario. Cameco is the operator of 3 facilities: the Blind River Refinery, the Port Hope Conversion Facility, and the Fuel Manufacturing Facility. The fuel fabrication facilities in Peterborough and Toronto belong to GE Hitachi Canada and operate under a single license. The 2013 performance ratings for the uranium processing facilities were determined, and CNSC staff have rated each safety and control area based on the results and observations from inspections and desktop reviews. For 2013, all of the uranium processing facilities received a satisfactory rating in all safety and control areas. GE Hitachi Canada also received a rating of fully satisfactory for environmental protection in recognition of the advanced pollution abatement technologies in place and their achievement of keeping releases of uranium to very low levels. The Blind River Refinery also received a rating of fully satisfactory for conventional health and safety in recognition of 8 continuous years without a worker lost time incident. Overall, these ratings indicate consistent management of safety systems at all facilities. The graph on this slide shows the maximum individual effective radiation doses for workers from 2009 to 2013. The red light on this chart displays the effective dose regulatory limit that a nuclear energy worker can receive in a year. As shown, the highest dose received by an individual worker at each of these facilities was below the annual dose limit of 50 millisieverts. These results also show that maximum individual effective doses to workers have been relatively consistent over time, and 2013 values that are representative of safe levels observed over the last 5 years. Similarly, this graph shows the average individual effective radiation doses to workers from 2009 to 2013. The average dose received by an individual worker at each of the uranium processing facilities was well below the annual dose limit of 50 millisieverts. This slide provides the dose to public from each uranium processing facility for 2013. Doses to the public from all uranium processing facilities continue to be well below their applicable regulatory and/or license limit. Trending at Cameco's fuel manufacturing facility shows a decreasing public dose from 0.042 millisieverts in 2011 to 0.013 millisieverts in 2013, resulting from improved storage practices of finished fuel bundles. To confirm the effectiveness of emission abatement systems and to monitor the impact of uranium emissions from the facility on the environment, all facilities, except GE Hitachi Canada in Peterborough, operate high-volume air samplers. A risk assessment for GE Hitachi Canada Peterborough has demonstrated that ambient air sampling is not required since the measured releases from the stack already result in levels lower than the Ministry of Environment standard for uranium in ambient air that will take effect in July of 2016. The results from the high-volume samplers for 2013 are shown in this slide and indicate that the maximum annual average concentration of uranium in ambient air measured around any uranium processing facility was much less than the Ministry of Environment air standard for uranium. These results indicate that all uranium processing facilities have controlled releases of uranium and that the environment and people are protected from airborne releases. Soil monitoring programs are intended to monitor the long-term effects of air emissions to show whether there is accumulation of uranium in soil in the vicinity of the facility. The slide shows the annual average uranium concentrations in soil. The data for all facilities is well below the most restrictive guideline, the Canadian Council of Ministers of Environment guideline of 23 micrograms per gram uranium for residential or parkland use. Soil sampling results in 2013 continue to indicate that current uranium emissions from the uranium processing facilities are not resulting in levels observed in soils that would pose a risk to people or to the environment. Moreover, these results verify that controls on uranium emissions within the facilities are effective at preventing the accumulation of uranium in soil. As shown on this slide, there were no recordable lost time incidents in 2013 at any of the uranium processing facilities. Because the frequency of lost time incidents have always been low at these facilities, there are no trends with respect to the number of lost time incidences reported to the CNSC. CNSC staff conclude that the uranium processing facility licensees have been implementing their conventional health and safety programs satisfactorily during 2013, and their programs were effective in protecting the health and safety of persons working in their facilities. In the next few slides, I will provide some specific highlights for each uranium processing facility for 2013, commencing with the Blind River Refinery. The Blind River Refinery operates a Class 1B nuclear facility in Blind River, Ontario. The refinery processes natural uranium ore concentrates into natural uranium trioxide. Cameco receives uranium ore concentrates from the mines and mills worldwide. In fact, approximately 80% of the world's uranium destined for nuclear power plants is refined at the Blind River Refinery. CNSC staff note that we will be utilizing the resources of the participant funding program to meet with the Mississauga First Nation community to discuss Cameco's Blind River Refinery operations and performance. This meeting is scheduled for October 15th, 2014, and the outcome of this meeting will be communicated to the Commission in the 2014 CNSC staff report on the performance of uranium and nuclear processing facilities. In 2013, CNSC staff conducted 3 compliance inspections, and the IAEA conducted 5 safeguard inspections. Of the 3 inspections conducted by CNSC staff, they focused on radiation protection, conventional health and safety, and environmental protection. Findings resulting from these inspections were mainly related to program and procedural adherence. None of the identified actions posed an immediate or unreasonable risk to the health and safety of workers, the public, or to the environment. Rather, the findings identified improvements which are required to maintain or to improve safety. There were 2 modifications to the facility's operations, processes, and safety systems in 2013. These modifications were reflected in a revision to the licensee's safety analysis report in 2012. The modifications included changes to the auger sampling or delidding station and the installation of whole body monitors at the main entrance to the facility. The modification to the auger sampling was the final corrective action taken as a result of an incident in June 2012 where a Cameco employee had a significant uptake of uranium concentrate. Details of this incident were reported to the Commission in the 2012 annual report. The installation of the whole body monitors was done to address a CNSC action item on improving the Blind River Refinery's contamination monitoring program. In 2013, no license limits were exceeded. This annual report describes 2 skin dose action level exceedances at the Blind River Refinery. Both instances involved Blind River workers exceeding the monthly skin dose action level of 10 millisieverts, with dosimeter results of 13.9 millisieverts and 14.6 millisieverts. This represents a small percentage, approximately 3%, of the CNSC's regulatory dose limit to the skin of 500 millisieverts. Cameco reported, investigated, and implemented corrective actions that were deemed acceptable by CNSC staff. Cameco has demonstrated the implementation of an effective occupational health and safety management program, which has resulted in Cameco's ability to keep their workers safe from occupational injuries. The refinery achieved 8 years without a lost time incident. The Blind River Refinery continued to operate within the framework of the Nuclear Safety and Control Act, and it met all requirements as per its operating license. Its conventional health and safety record is excellent, and overall, this facility operates safely. I will now discuss the Cameco fuel manufacturing facility. Cameco Fuel Manufacturing operates a Class 1B nuclear facility in Port Hope, Ontario, where they primarily produce natural uranium dioxide fuel bundles for CANDU reactors. In 2013, there were several modifications to the facility. Major improvements include upgrading the sintering furnace, a new extraction unit in the ceramics laboratory, and improvements to the fire protection system. All modifications to the facility with a potential to impact to safety are evaluated through Cameco's internal change control and design change control process. The 2013 modifications did not alter the licensing basis and were within the safety case described in the licensee's safety analysis report. Several program and procedure documents were also updated, including the waste management procedure, to reflect Cameco's waste minimization efforts that were accepted by the CNSC in 2012. 5 inspections were completed in 2013. CNSC inspections include core checks to verify that the license is taking appropriate measures to protect the public, the environment, and the workers. In addition, the inspections include focus areas to assess the health of various programs. The focus areas for 2013 were environmental protection, emergency preparedness and response, management system, and security. From the inspections, CNSC staff can confirm that CFM is operating the facility safely. Improvements in program documentation, records, and administration were requested by staff. CFM is taking appropriate actions to address the findings. As previously reported to the Commission in February 2013, Cameco discovered errors in the internal dose calculations. These errors were corrected, and Cameco workers' dose results were recalculated from 2013 to 2011. The investigation revealed that no regulatory dose limits were exceeded, as the recalculated annual maximum effective dose to workers remained well below the annual regulatory dose limit of 50 millisieverts. Cameco reported this event to the CNSC in a timely manner and notified all affected workers of their recalculated internal doses. CNSC staff reviewed the recalculated doses along with the corrective actions taken by Cameco, and CNSC staff are satisfied that the measures taken to resolve this issue. One transport event was reported during the 4th quarter of 2013, in which 5 drums filled with uranium dioxide production scrap were transported from the CFM facility to the Port Hope conversion facility, with inappropriately applied lids. Cameco reported the incident to the CNSC, completed an investigation of the incident, and implemented corrective measures. There were no releases to the environment, nor dose to workers from this event. Cameco reported 2 action level exceedances in 2013 that involved 2 separate occasions where 2 Cameco workers' quarterly internal doses were determined to be 0.82 millisieverts and 1.02 millisieverts, respectively, slightly above Cameco's internal dose action level of 0.8 millisieverts per quarter. In both instances, Cameco reported, investigated, and implemented corrective actions as required. CNSC staff is satisfied with Cameco's response to these action level exceedances. And finally, there were no lost time accidents and no action level exceedances related to environmental protection at this facility. The Port Hope Conversion Facility is located in the municipality of Port Hope, Ontario, situated on the north shore of Lake Ontario. The Port Hope Conversion Facility primarily converts uranium trioxide powder produced by Cameco's Blind River Refinery to uranium dioxide and uranium hexafluoride. Uranium dioxide is used in the manufacture of CANDU reactor fuel, whereas uranium hexafluoride is exported for further processing into fuel for light water reactors. During 2013, there were no significant process modifications that affected safety significant systems, and no license limits were exceeded. Following the acceptance of the environmental assessment for the Vision 2010 project, now referred to Vision in Motion by the Federal Minister of the Environment, work is being undertaken by Cameco to identify the project scope for implementation. Cameco's focus in 2014 will be to move forward with the project planning and licensing activities, with the intention of applying for an amendment to the Port Hope Conversion Facility operating license in 2014 or 2015 to authorize activities for this project. CNSC staff find that groundwater quality across the Port Hope conversion site has remained stable, and there has been no change in harbor water quality. CNSC staff continue to engage with the Ontario Ministry of Environment staff, as well as staff at Environment Canada, who also have an interest in these groundwater releases. The Port Hope Conversion Facility's soil monitoring program includes annual sampling in the municipality, including the Waterworks parking lot located adjacent to the facility. The average uranium in soil concentrations in 2013 remain similar to past years. This indicates that the current uranium emissions from the Port Hope Conversion Facility have had no measurable impact on soil. In 2013, CNSC staff conducted 6 compliance inspections, and the IAEA conducted 5 safeguards inspections. Of the 6 CNSC-led inspections, CNSC staff focused on management system, radiation and environmental protection, conventional health and safety, emergency preparedness, transportation, and security. The majority of the findings from these inspections were related to program and procedural adherence. None of the resulting actions raised in the inspection reports posed an immediate or unreasonable risk to the health and safety of workers, the public, or to the environment. There were 2 monthly gamma action level exceedances at one of Cameco's fence line monitoring locations. The UF6 cylinders causing the elevated gamma dose rate were moved, and fence line gamma levels were closely monitored following these exceedances. The CNSC staff visited the site following report of these exceedances and are satisfied with the actions taken by Cameco and confirm that doses from this facility remain well below the public dose limit. Cameco also reported 2 events to the CNSC in 2013 at the Port Hope Conversion Facility. The first, in February of 2013, relates to a UF6 cylinder valve which was bent when the valve cover came in contact with the door frame when backing out of the building. The emergency response team was activated, there was no release to the environment, and corrective actions implemented by Cameco have been reviewed by CNSC staff and found to be adequate. The second event, in June of 2013, involved discharge drum rupture discs in the UF6 plant, which failed prematurely due to nickel fluoride corrosion. This caused a small fluorine fire. The facility was shut down safely with no injuries, no environmental releases, and minimal damage to the plant. CNSC staff are satisfied with the corrective actions initiated by Cameco to prevent future reoccurrence and continue to follow up with compliance verification activities. There were no lost time incidents in 2013. I will now discuss GE Hitachi Canada's facilities in Toronto and Peterborough. Please note, follow-up actions resulting from the Commission meeting that was held in Toronto in December of last year will be discussed at the end of this presentation. GE Hitachi is a Canadian company that operates 2 Ontario sites under 1 CNSC license, 1 site in Toronto, 1 site in Peterborough. GE Hitachi manufactures nuclear fuel bundles from uranium dioxide powder. In 2013, GE Hitachi Canada added a fire separation wall between buildings in Peterborough and also added electrical supervision of two fire protection valves to improve overall fire safety at its Peterborough plant. GE Hitachi Canada also upgraded automation equipment controls and guarding to improve safety. Security improvements were also made at the Toronto facility. All changes were within the licensing basis and did not change the safety case as described in the Facility Safety Analysis Report. In January 2013, as mandated by the CNSC, GE Hitachi Canada submitted a revised public information program to meet CNSC's new regulatory requirements. This program's implementation and its performance was the subject of a CNSC inspection in June of 2014, which resulted in enforcement actions towards improvement of their public information program. Overall, CNSC staff find that GE Hitachi Canada's public information program meets the intent of CNSC requirements and is commensurate with the type and risk of its facility. In 2013, CNSC staff conducted 2 inspections at GE Hitachi Canada that focused on safety and control areas of radiation protection, environmental protection, conventional health and safety, security, and waste management. Enforcement actions were raised, of which 2 related to the waste management program, which remain open. CNSC staff are satisfied with the schedule to address these actions and to continue to follow GE Hitachi's progress in this area. For 2013, there were no license limits nor action level exceedances related to GE Hitachi's air and liquid effluents. There was 1 radiation protection action level exceedance for internal dose, wherein urinalysis results from an operator reported 13.5 micrograms per liter uranium against an action level of 10 micrograms uranium per liter. GE Hitachi Canada reviewed its personal protection equipment training and practices and implemented corrective actions to its procedures as a result of this event. CNSC staff found the licensee's corrective actions to be satisfactory. GE Hitachi Canada maintains a satisfactory program for conventional health and safety with no lost time injuries reported for 2013. I will halt the presentation at this time to answer any questions you may have.
I think I think we confused ourselves here because you are going to talk later on about all the action that. Why don't you? Maybe it'll throw all of us off, but why don't you continue on the GE Hitachi so we can open up the question for all of this?
Thank you. I will now turn the presentation to the nuclear substance processing facilities. There were 3 nuclear substance processing facilities, all of which are located in Ontario. SRB Technologies is a tritium processing facility located in Pembroke, Ontario. Its license will expire in 2015, and a renewal hearing is currently scheduled for May of 2015. Nordion possesses nuclear substances and is located in Ottawa, Ontario. Nordion's license will also expire in 2015, and a renewal hearing will be held in late summer of 2015. Shield Source Incorporated, or SSI, was a tritium processing facility located in Peterborough, Ontario. SSI was issued a license to abandon in March of 2014, and the facility is no longer under CNSC regulatory oversight. The building that SSI was located is, however, safe and available for any industry to use for other non-nuclear processes. CNSC regulatory oversight of SSI in 2013 was intensive, with site inspectors on site during all cleanup and remediation activities to ensure worker protection and protection of the public and the environment. In 2013, doses to workers at Nordion remained very low, with a maximum annual effective dose of 6.4 millisieverts and an average effective dose of 0.6 millisieverts. Doses to workers at SRB also remain low, with a maximum annual effective dose of 1.9 millisieverts and an average effective dose of 0.2 millisieverts. The graph on this slide shows the maximum average individual effective radiation doses of both facilities. The red line in this chart displays the effective dose regulatory limit that a nuclear energy worker can receive in a year. As shown, the highest dose received by an individual worker at each of the facilities was below the annual dose limit. This data shows that doses to individual workers are safe and radiation protection programs at both facilities have been effective. There were no lost time injuries at SRB Technologies. There was one lost time injury at Nordion in 2013 and was the result of an employee bending over to pick up a portable piece of equipment and experienced pain in their lower back when standing. The injury resulted in 18 days of lost time. Overall, CNSC staff rated all safety and control areas for Nordion as satisfactory, with the exception of conventional health and safety, environmental protection, and security, which are rated fully satisfactory. Despite a single lost time incident, Nordion maintains a strong program for conventional health and safety. In recognition of this program, Nordion was recognized in 2013 by the Canadian manufacturing industry as one of Canada's safest employers in the category of manufacturing, and is also recognized in CNSC's evaluation of the conventional health and safety programs with a fully satisfactory rating. Nordion also maintains programs for environmental protection and security to a level that warrants rating to fully satisfactory. Similarly, for SRBT, CNSC staff rated all safety and control areas as satisfactory, with the exception of conventional health and safety, which is rated fully satisfactory as a result of its consistent record of worker protection. I will now discuss SRB Technologies in more detail. SRB Technologies is licensed to process tritium gas to produce gaseous tritium light sources and manufacture different radiation devices containing these sources. SRBT operates under a license issued in 2010 that expires in 2015. The SRBT facility was inspected once in 2013 with a broad focus covering the safety and control areas of environmental protection, radiation protection, conventional health and safety, training, operational performance, and packaging and transport. During 2013, the average annual effective dose received by workers at SRB was 0.2 millisieverts. CNSC staff are satisfied that SRBT is keeping doses to workers as low as reasonably achievable. SRBT continues to effectively control air and liquid releases from their facility, and all releases remain consistently below license limits. The most exposed member of the public would receive a dose of 0.0068 millisieverts per annum as a result of these releases. In 2013, there were no lost time incidences at SRB, and SRB continued to operate within the framework of the Nuclear Safety and Control Act and met all requirements as per its operating license. I will now discuss Nordion Canada Incorporated in more detail. Nordion Canada Incorporated is a nuclear substance processing facility located in Ottawa, Ontario. Nordion processes unsealed radioisotopes such as iodine-131 for the health and life sciences and manufactures sealed radiation sources for industrial applications. Nordion also exports cobalt-60 around the world. In 2013, CNSC staff conducted 3 inspections at the Nordion facility that included environmental protection, radiation protection, fire safety, and conventional health and safety, as well as transport, packaging, and security. Enforcement actions were raised during these inspections. At this time, what item remains outstanding? The item pertains to nuclear substance inventory record improvements. CNSC staff is satisfied with Nordion's follow-up and will continue to monitor Nordion's progress in this area. No regulatory limits were exceeded during the current license period. Nordion was acquired by Sterigenics in July of 2014. Nordion still operates under the same name. However, the Class 1 nuclear substance operating license was transferred to reflect Nordion's new corporate identity. The only change in the CNSC license is a new corporate number. During 2013, there were no significant process modifications that affected safety significant systems, and no license limits were exceeded. Air emissions and liquid releases from the Nordion facility continue to be effectively controlled and monitored. No action level exceedances occurred in 2013. Nordion's commitment to keeping releases as low as reasonably achievable is demonstrated by maintaining very low emissions and their ISO 14001 certification. Under separate licenses, Nordion is issued independent of Nordion's Class 1B facility license. Nordion exports cobalt-60 under these separate licenses. 489 such licenses were issued to Nordion from August 2010 to June of 2014. These licenses authorized 605 exports of cobalt-60. There were 17 occurrences of noncompliance with post-shipment verification since 2011. Graded compliance enforcement resulted in an administrative monetary penalty that was issued to Nordion in September of this year. Nordion's performance under these export licenses was considered below expectations. I will now provide an update regarding the Shield Source Incorporated facility. Shield Source, or SSI, was a tritium processing facility located at the airport in Peterborough, Ontario. The SSI facility was remediated and decontaminated in 2013. The facility was cleaned up and met all regulatory requirements for its release. Releases from the facility during 2013, while cleanup activities were being conducted, were much less than releases from the facility during operation. Worker exposure to tritium was also much lower during cleanup activities than during the operation of the facility because tritium was no longer being processed. As of April 2014, the facility was released from regulatory control, and the facility is now a safe work environment for any non-regulated business or industry. CNSC staff continue to monitor the environment near the SSI facility for the purpose of improving our understanding of how tritium cycles in the environment. The results indicate that tritium concentrations in soil, surface, and vegetation continue to decrease as expected. A report is being developed and will be posted on the CNSC website for members of the public who may have an interest in the status of the environment near this facility. During operation, the primary critical receptor was a resident living across the road from the airport whom used a groundwater well for the supply of drinking water. Tritium was never detected above the detectable limit in this well during operations. The airport authority recently purchased this property, and it is no longer a residential home. Moreover, the airport intends to decommission the groundwater well at this site, and it will no longer be a point of potential exposure to members of the public. In conclusion, for this annual performance report, the CNSC compliance activities for 2013 confirm for uranium and nuclear processing facilities, all 14 safety and control areas were rated as satisfactory or better. Radiation protection programs were effective to keep doses as low as reasonably achievable. Environmental protection programs were effective at keeping environmental impacts as low as reasonably achievable. And finally, conventional health and safety programs continue to protect workers. These results demonstrate that the uranium processing facilities and the nuclear substance processing facilities have operated safely in 2013 and that the environment and the Canadian public continues to be protected. I will now provide updates to the Commission on other matters of regulatory interest. On January 29, 2014, Camel Corporation reported to the Canadian Nuclear Safety Commission of an event that occurred on January 28, 2014 at the Port Hope Conversion Facility, located in Port Hope, Ontario, where Cameco reported loss of computer control that is associated with hydrogen gas and fluorine gas production in the UF6 plant. This resulted in multiple electrolytic cells being drawn into a state, and in some instances, hydrogen and fluorine gas separation was lost within individual cells. This could have caused, but didn't, an explosion or seriously damaged the UF6 plant. The Commission was informed of this event in February 2014, and a status update was provided to the Commission again in June of 2014. At the request of the Commission, a detailed memo is being prepared to provide additional information on this event, including a summary of the processes in the UF6 plant, the safety and control measures that were in place, and how these safety and control measures performed during the event. CNSC staff note that there were no worker injuries, no dose limits exceeded, and no releases within or outside the plant as a result of this event. With respect to the 2013 annual report, the management system and human performance management, which includes training, for Port Hope Conversion Facility are rated as satisfactory despite this event. As a result of this event, however, the CNSC staff have heightened regulatory oversight of the facility for 2014. The outcome of this heightened regulatory oversight and its impact on the performance ratings of the relevant safety and control areas will be reflected in the 2014 annual report. I would like to provide an overview of the work undertaken by CNSC staff following the Fukushima nuclear accident that happened in 2011. In 2011, a CNSC directive was issued requiring uranium and nuclear processing facilities to review their safety cases and report on implementation plans for short-term and long-term measures to address any identified gaps. Licensees for uranium and nuclear substance processing facilities have completed all of their improvement initiatives, including a flood modeling reassessment for the Blind River Refinery and an assessment of critical spare parts at the Port Hope Conversion Facility. CNSC staff are satisfied that all uranium and nuclear substance processing facilities have completed their facility-specific improvement initiatives to address lessons learned from the Fukushima accident. Best Electronics was issued a Class 1B nuclear substance processing facility license effective July 1, 2014. In the decision to issue the license, the Commission requested that Best Electronics have an acceptable financial guarantee included in the License Condition Handbook by no later than January 31, 2015. The Commission also requested a progress update in October of 2014. On September 12, 2014, CNSC staff received a revised financial guarantee from Best Electronics. CNSC staff are currently reviewing the document, can confirm that the proposed financial guarantee vehicle is similar to the one discussed by CNSC staff at the May 2014 hearing. The Commission will be requested to determine the acceptability of the financial guarantee following staff's review. At the December 2013 Commission meeting, GE Hitachi Canada was tasked by the Commission with 5 action items related to uranium in soil and aspects of GE Hitachi Canada's public information program. The following provides a status update of these 5 actions. Action 1. GE Hitachi Canada reported elevated uranium in soil values in 2012 in a localized area near its fence line adjacent to the rail line. In the December 2012 meeting, GE Hitachi Canada committed to the Commission to review possible remediation options. Subsequent detailed characterization of the area showed an average of 3.2 parts per million uranium and a maximum of 12.2 parts per million uranium. This is below the values previously sampled and well below the guideline value of 23 parts per million for residential and parkland use. GE Hitachi Canada is in the process of discussions with the adjacent landowner about remediation options, if any. CNC staff considers this action to be open and will continue to track. Action 2, GE Hitachi Canada was directed by the Commission to post the emergency response plan on its website, excluding protected sections, and consider other means of informing the community about this plan. GE Hitachi Canada has added a summary of their transport emergency response plan as committed and informed the committee through its April 2014 community newsletter, which was delivered to approximately 800 residents. Staff opinion, based on community feedback, is that GE Hitachi Canada could do additional promotion of these postings on their website to ensure better community awareness. CNSC staff continue to monitor progress in this action and consider it open and will continue to monitor progress. Action 3, GE Hitachi Canada was tasked by the Commission to provide details on insurance arrangements, 2, evaluation of worst-case scenarios and potential consequences, and possibly publish this information on the company's website. And 3, release the name of the third party who conducts verification of GE Hitachi's environmental monitoring systems. The first action was completed by GE Hitachi Canada through a letter to the CNSC. The second action, GE Hitachi Canada posted a video on its website that detailed its operations in Toronto, its safety practices, worst-case scenarios, and its consequences. The third action was completed by posting the third party's name on GE Hitachi Canada's website. CNSC staff consider Action 3 to be now closed. Action 4. GE Hitachi Canada was directed by the Commission to post better information on transportation of uranium dioxide and fuel pellets, as well as put information on emergency drills in the public domain. GE Hitachi Canada has added a video on these issues, as well as committed to providing public disclosure of future emergency drills and related activities on their website. GE Hitachi Canada is in the process of identifying future activities like emergency drills with the Toronto Police and Fire Department that can be published in the public domain for additional information. CNSC staff continue to monitor progress on this action and consider it to remain open, and will continue to monitor progress in this area. And finally, Action 5. In 2013, GE Hitachi Canada implemented a revised public information program as mandated by the CNSC. This included an updated website, an improved newsletter, a newly formed Community Liaison Committee, and several outreach activities to community members and local, provincial, and federal elected representatives. Subsequent to the 2012 Commission meeting, GE Hitachi Canada also involved additional corporate resources to enhance their website content, format, and information presented, and have added information as requested by the Commission. CNSC staff have continued to monitor GE Hitachi Canada progress in this matter through quarterly reports and a 2013 annual compliance report. As well, as part of the CNSC's compliance verification plan, staff have inspected and will continue to do so the public information program of GE Hitachi Canada. Several enforcement actions have been provided to GE Hitachi Canada as part of the recent inspection that included improvements to GE Hitachi Canada's target audience, program objectives, its communication products, and their program review and process and feedback process. Staff have also emphasized the need for GE Hitachi Canada to continue to be proactive in its public outreach. Overall, CNSC staff find GE Hitachi Canada has implemented a public information program that meets the intent of CNSC's regulatory requirements and is commensurate with the type and risk of this facility. This concludes our presentation. I will now pass it back to Mr. David Newland.
Thank you very much, Mike. That completes our presentation, and we're now prepared to take any questions that the Commission may have. Thank you.
Thank you.